To start off today's review, we're going to look at some definitions here in Chapter 4, Section 1. First, what is a prime number? If the only numbers that can be divided into the dividend with no remainder are the numbers 1 and itself, the number is prime. And the divisibility test that we're going to be speaking of later that all fail when you try to run them. It's important to know that prime numbers continue infinitely. However, its need extends mostly to the primes around 50 or so, or under 50 or so. The list to be considered follows. Read over the list a couple times to familiarize yourself with the numbers. You don't need to memorize it, but being familiar with the numbers will be of great help as you continue with your math studies. So let's read the list together. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. We'll stop there. It's quite the list, but it goes on, like we said, forever. Let's do it again. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. Let's talk about what a definition for divisible. What does it mean for one number to be divisible by another? One integer is divisible by another if the remainder is 0 after you divide. For example, 15 divided by 3 is 5. The number 3 divides into the number 15 evenly, so there's no remainder. What's a factor? A factor, one integer is a factor of another non-zero integer if it divides that integer with 0 remainder. Let's move on to objective 1, using divisibility tests. There are divisibility rules, tests that may be used to help determine if a number is prime or not. Prime numbers cannot be factored any further. The numbers that are not prime need to be factored until all that remain are prime numbers. Another way to think of it is the product of two integers is an integer, and both integers are factors of that product. Moreover, both integers divide the product, and the product is said to be divisible by each of the integers. Divisibility rules for 2, 5, and 10. An integer is divisible by 2 if it it is divisible by 2 if it ends in 0, 2, 4, 6, or 8. In other words, is it even? It's divisible by 5 if it ends in 0 or 5. And it's divisible by 10 if it ends in 0. That's probably the easiest one. How about divisibility rules for 3 and 9? An integer is divisible by 3 if the sum of its digits is divisible by 3. An integer is divisible by 9 if the sum of its digits are divisible by 9. We'll see some of those in future slides. Example 1. Divisibility by 2, 5, and 10. Is the first number divisible by the second number? 567 by 2. And as you can see here, it says no, it's not. 567 does not end with a 2, a 4, a 6, an 8, or a 0. So it is not divisible by 2. How about 1015? Is it divisible by 5? Yes. 1015 ends in the number 5. How about 111,120? Is it divisible by 10? And the answer is going to be yes. It's 111,120 is divisible by 0 because it ends in a 0. Okay, for example 1, let's do some check your understanding. Is 160 divisible by 5? Well, the rule said that if the number is divisible by 5, if it ends in what? It has to end in a 0 or a 5. If it ends in a 0 or a 5, it is divisible by 5. So the answer is yes. How about B? 56. Is that divisible by 10? Does it end in 0? No, it ends in 6. So it is not divisible by 10. 53? Is 53 divisible by 2? Well, it talks about ending. The number that ends, right, is a 3, a 2, a 6, or 8. No, no. It's an odd number, so it is not. No, it is not divisible by 2. And how about 1,118? Is that divisible by 2? Well, as we can see here, that the 8 ends in an 8. Well, that means that it's even, and any number that's even is divisible by 2. So the answer is yes, it's divisible by 2. Okay, now let's get into some of those divisibility by 3 and 9. A little more interesting. Is 567 divisible by 3? Same number as before. The answer is yes. Why is that? Because 5 plus 6 plus 7 equals 18. 5 plus 6 is 11, and 11 and 7 is 18, and 18 is divisible by 3. How about 1,015? Is that divisible by 9? Whoa. Well, let's try. 1 plus 0 is 1, plus 1 is 2, plus 5 is 7. And 7 is not divisible by 9, so the answer here is no. 1,015 is not divisible by 9. It's pretty easy to check, though, as you're moving along. As you remember from last time, it is divisible by 5. But so let's see. Now we're going to go up to the next slide. We're going to check our understanding of the divisible by 9 and 3. Is 64 divisible by 9? So what do we have to do to find out? We have to take 6 and 4. 6 plus 4 is equal to 10. Is 10 divisible by 9? Is it even if we do that? No. So no is the answer on this one. How about 472? Is it divisible by 3? Well, what do we have? We have 4 plus 7 is 11, plus 2 is 13. Is 13 divisible by 3? No. How do we know it's not? First of all, remember that list that we were reading off. 13 was one of those numbers, one of those prime numbers. And it only has factors of itself and 1. So the answer is no on B. How about here on C? Is 174 divisible by 3? So 1 and 7 is 8, and 8 and 4 is 12. And is 12 divisible by 3? 12 divisible by 3, and that happens to be 4, so the answer is yes. Y-E-S for this. Now let's try 9 and letter D. Is 43,542 divisible by 9? Well, what are we going to do? We're going to take 4 plus 3 is 7. 7 plus 5 is 12. 12 plus 4 is 16. 16 plus 2 is 18, so the number ends up being 18. And is 18 divisible by 9? The answer is yes, because it's 2. 9 times 2 is 18. Okay, we're on objective 2 now. So we've gotten through those prime numbers and factoring. So now we're going to look at how to find factors. Finding factors, objective 2. The process of finding the factors of a number can be somewhat repetitive. but the repetitive nature of this process makes the process easier. Start by listing the main numbers as the main number and 1 as factors. Take, for instance, the number 12. The two numbers to consider here are 1 and 12. Put them into two columns and then repeatedly factor out the primes from the main number until only primes remain. As you divide out the primes on the main number, multiply the second number by that same prime. You'll see why as we get going forward. This process will result in having the factor pairs at each step of the way. So as you see, for instance, 12 times 1 is what we're working with. We're factoring 12. And we're going to find the factors of 12. And they are what? 1, 2, 3, 4, 6, and 12. Those are the factors. So let's go down and make the two columns. On the factors, we're going to start with a 12 and a 1. Okay. The first thing we're going to do then is we're going to take the smallest prime number we know of that we work with, and that's the 2. And we're going to continue with the 2 until numbers that the number no longer divides by 2. And then we'll check for other numbers, primes, 3s, and whatever, 5s, or whatever the case might be. At that point, we'll continue on moving up the stream of the primes. That's why I said it's important to kind of memorize those, not memorize, but have good familiarity with the prime numbers, at least the small ones. The 2, 3, 5, 7, 11, 13. Those are, you're going to run into them quite often in these problems. So you take the 12 and you divide out a 2. Is it divisible by 2? Yes, because it ends in a 2. So you divide that by 2 and you get a 6. You see it right here, you get the 6. If you take the 6 now and you the 6 and write it down here, and then take the 1 and multiply it by 2, by 2, you get a 2 as your answer right here, 2. So now you take the 6. Take the 6 and divide it by 2 again. It is divisible by 2 because it ends in 6. It's an even number. So now you write down the 3 here, and then you multiply the 2 by the 2 that you just divided into the 6, and you get a 4. Okay? Then you take the 3 and you say, is it divisible by 2? And you say, no, it's not. So what's a prime that we can divide it by? Well, let's try 3. Well, 3 divides into 3 perfectly at one time. And then if you take the 4 over here and multiply it by the 3, you get 12. So we've completed because we've gone all the way from the 12 here, come all the way down the columns, and now we have the 12 at the bottom on this side. So let's go on over that again. We did the 12 divided by 2 to start with 2's. We got a 6. We multiplied the top number here of the column, the 1, by the 2, and you get a 2. Go down to the next. You take the 6. Does it divide by 2? Yes, it does. So divide it. You divide by 2, you get a 3. Multiply the 2 by 2, because you're multiplying by that factor now, and you get a 4. So here's the 4 right here. So now that you've got the 4 here, you got a 3 here, can you divide the 3 by 2? No, you cannot. So since you can't divide the 3 by 2, we're going to try a 3. And yes, it does. So that's the last factor. So we have, as you see here, we divided by a 2, we divided by a 2, and we divided by a 3. We're all primes. There's nothing left. We're down to a final prime. That 1's not a prime number, by the way, but we're down to a 1. We can't go any further. And we've taken this 4 and we've multiplied the 4 by the prime that we divided into here, and that's where we got the 12. So now we've gone complete the full circle from here to here. We've got this, we started with a 12 up here and we ended with a 12 down here. There are no more factors. Okay, so what are the factors? We said it right up here in the top, that the factors are right here, 1, 2, 3, 4, 6, and 12. And how do we do it? They got 1, 2, 3, 4, 6, and 12. Just take all, and here this is the repeat of the top. So if you take the top ones, or don't take the top ones, and just look at the factors that you created, you have a 1, 2, 3, 4, 6, and 12. Put them in order, however you want to deal with it. But those are the factors. Those are the factors of 12. Okay, for example 3, let's check our understanding. The directions here. List the positive factors of each integer. So we're going to start off with, in this case, we're going to start off with the 10. What are the positive factors of 10? Well, we're going to start with a 10 and a 1, and we're going to divide the 10. We're going to see if 2 divides into 10, and it does. It's an even number. So we're going to get 10 divided by 2, we're going to get a 5, and we're going to take 2 times 1, and we're going to get a 2. Okay, those two multiply together, 5 and 2, to make a 10. Now, is 5 divisible by 2? No. Is it divisible by 3? No. Yes, it's divisible by 5, a prime number 5. We learned those prime numbers earlier, 5. So the answer here is a 1, and then 2 times 5 is 10. So the numbers that we're dealing with here, the factors, are 1, 2, 5, and 10. Let's try 21. How about 21? So we have a 21 and a 1. Well, is 21 divisible by 2? Nope, it's not an even number. 1 is not even. How about is it divisible by 3? Well, let's run the divisibility test. Is 2 plus 1, which is 3, divisible by 3? Yes, it is. So 21 is divisible by 3. So if we divide by 3, we get a 7. And we multiply 1 by 3, we get a 3. 7 times 3 is 21. How about any others? Well, if we take a 7 is not a 3, not a 5, but you can divide it by a 7, another prime number, which is 1, 3, 5, 7. There's fourth one. Or 2, 2, 3, 5, 7. Excuse me for that mistake. We get 1, because we take 7 divided by 7, get a 1, and we take the 3 multiply by 7, and you get 21. Okay, we've come full circle. We talked about the 21 here, 21 here. The factors of 21 are those 1, 3, 7, and 21. How about 24? The factors 24 and 1. Divisible by 2? Yes. The answer, the 2, you get a 12 and you get a 2. Is 12 divisible by 2? Yes. You get to divide 2, you get a 6, and you get a 4. Multiply 2 times 2, you get a 4. Is 6 divisible by 2? Yes. You get a 3 here, and the 4 times 2 is what? 8. 8. Now, is 3 divisible by 2? No. How about divisible by 3? Yes. So you have a 1 because you divide by 3, and you take the 8, multiply it by 3, and you get a 24. Full circle, all the factors of 24 are right here. 1, 2, 3, 4, 6, 8, 12, and 24. Let's go over here to 31. Is 31 going to be divisible by anything? It almost looks like a prime number if I remember my list. We'll find out. Put 31 here and a 1 over here. Can we divide 2's into it? No. Can we divide a 3? No, that 1 plus 3 is a 4. That's not divisible by 3. How about is divisible by, what is it divisible by? 4, we don't count 4. 5, no, 5, it doesn't end in a 0 or 5. 6, nothing's going to go into this thing. So that's the answer. 31 goes into 31 one time, and 1 times 31 is 31. So the only the numbers here is 31 is the only, and 1 are the only factors. And since 1 and 31 are the only factors of 31, that makes prime number of 31. Okay. So now in E, it says, what are the possible arrangements for example 3? That's where we had the 5 student minimum limit of students in the singing. If there are 36 students singing, but we still have the same rules, they could only have 5 is the minimum. So what are the factors of 36? Let's find out. But what is it that we can't do? Like we showed, we can't go below 5 once we get to 5. So 36, our numbers are 36 and 1. So 36, we can divide the 2 is going to give us an 18, and we're going to get a 2. We can divide this by 2, yes, so we're going to get a 9, and we're going to get a 4. Because 9 times 4 is 36. We're going to get a 4. Now, What else can we divide into 9? Can we divide another 3? We can divide we can divide a 3 into 9, and we get, at this point, we're going to get a 3, and we're going to get a 12. 3 times 4 is 12. Well, the rules said that we couldn't have less than 5. So the factors that we can have here are 36, 1, 2 and 18, 9 and 4. They have to be even rows, right? So we could have 3 and 12, but we can't have less than 5. So these are excluded. So the factors that we can have a row of 36 students, one row. We can have 2 rows of 18 students, or we can have 4 rows of 9 students and have even rows. Okay?